let's take a look at the random forest regressor parameters. Okay, you can see here the number of estimators. This is the number of decision trees to set up 100. We can modify that. We're going to modify the max depth. There's no default here. Now the max features here is set to 1.0, and that means it's looking at all of the columns. Contrast this with the random forest classifier. It says max features are the square root of the number of columns. So you have 9 columns, it's only considering 3 when looking at making the splits. So let's just start with in estimators max depth, excuse me, and max features, and see if we can make some progress. Okay, so how do we do that? Well, we were already tweaking the max depth. One of the things I'm going to do is the scores were not better, if you remember, when we got rid of the information. So I'm actually going to go back now and comment this out. So I'm going to keep those extra columns we had. Okay, and we'll get a new score here. The max depth of 10, and not particularly good, but that's okay. It's a different split. Okay, so let's try something like a max depth of 6. Now for in estimators, more can sometimes overfit. We could try a little less. We can also try more. It's not clear what's going to improve. And note here, when I'm inside of the parentheses, it's showing the different options. It shows max features, okay? And you could actually do these by percentages. So instead of looking at all of the possibilities, let's only consider, say, 70% of the rows when making a split, or even 60. Okay, so let's see now what we get making these changes. Okay, not better. Maybe more decision trees will help. Let's try 200. Okay, slightly, not too much better. The max depth could be off here. Like, what if we go down and we try 4? Okay, it seems like it's not finding enough detail. So if we go up toward 10, okay, we're getting slight improvements. And this in estimators could be anything. Like we could double it. Let's try 400. I sometimes like to use in estimators later because it is sometimes true that later will do better. And for this max features, you could go in either direction. Okay, you could try less, okay, which allows for more variation when it considers its splits, and you could also go for more. Okay. This is not an easy one to make progress with. So, and out of curiosity, we can try that different split thing. Do we have like a tougher, split than another? Well, it's pretty comparable. Okay, so what else can we change in the random forest regressor? We can change the minimum samples that are required for a split, which is similar to the minimum samples for a leaf. This is the predictions, and it says, you know what? We're not going to go all the way down to 1. Like we'll say, if you have like 4 leaves, we'll stop. Something like that. Now, before making these kinds of determinations, it's good to know the size of your data. So with df shape, okay, let's figure out how big is this data. It's substantial. It's got 4,177 rows. Okay, so we put in min samples leaf, and this is saying, hey, if you get down to let's go with 5, we're stopping there. We're not going to continue to split the data because we don't want to overfit it. Okay. And so let's just try that one as an add-on in itself. See if it shows any improvement. I always think it's I think it's personally fun when you have sort of data sets that are more challenging to kind of get solid predictions from. It could be worth looking at too. It looks like everything is, everything's normalized, which is good, I think. Okay, maybe we'll do one more of these samples here. Let me just look at these. Now, when you're on your own, you can certainly scroll down and gain information about these. Some of these, by the way, the criterion is how it's like doing things like choosing the splits, not necessarily how the model is varying. kind of, I don't know, like we could try some different things here. Min sample split, the number of samples required to split an internal node. That's an interesting one. Min weight fraction leaf. The minimum weighted fraction of the sum total of weights required to be at a leaf node. You can see some of this requires like some more knowledge. You know, the max features one we've been considering, like again, you can use percentages, which is what I'm using. Just checking out some of these different ones. I wanted to look at max samples. If, you know, so if Bootstrap is true, the number of samples to draw from X to train each base estimator, and it's saying it should be within a percentage, okay? And so this is an interesting idea. So instead of sort of taking all the rows, you could take a smaller amount. Okay, so we could try that. I believe the default is Bootstrap is true. I think we definitely want this to be bootstrapped. Yeah. So let's try max samples. Okay, that could be interesting. That's comparable to max features. And let's say instead of taking all of the rows, we just take 0.8. Why could that be advantageous? Well, if you have 100 trees, you have some problematic rows, you know, maybe you could fit things a little more nicely some of the time. Okay, I think we did get an improvement, which is interesting. And so when that happens, we can say, well, what if we go down? What if we take both of these down? Just a little bit. And what we're doing here, this is the process of working on fine-tuning sort of a model. You know, we'll look later at using grid search CV and randomized search CV to do this. And once you do that too, you could try shifting some other criteria and see kind of how it goes. You know, it looks like, well, if you go down and your score's a little worse, you know, you could go up, maybe it'll get better. You know, and so we're kind of hovering around 55% for this. We'll try to do some more work on this, but I want to address one thing that's sort of crucial, which we saw to like greater effect with other data sets, and that was when you get the different splits, right? It seems like a problem that, hey, like depending on how we split the data depends on the score that we get. Now, in this case, you know, we're doing all these like specialized kind of estimations, and so it's not having as big of an effect, but you don't want to have to resplit your data to see if it is in fact going to give you like a different score every time. So we're going to address that now.